Now let's see what happens when your auxiliary equation has complex roots. And in particular, let's try to solve y double prime plus y equals 0. In this case, the auxiliary equation is r squared plus 1 equals 0. So r squared is minus 1, and therefore r is plus minus root of minus 1, and r is plus minus I. Now, by analogy with distinct roots, and it's really still the same because of the factoring method, this means that y is ae to the it plus be to the minus it. However, this is very strange because we start with the real differential equation, which models real processes, like oscillations, for instance, but here we have a complex solution, which we do not like very much. So the question is, how do we get real solutions from this? How to get real solutions from this? I mean, let's get real. From this. And the trick is really in Euler's formula, because what is e to the it is none other than cosine of t plus I sine of t. And what is e to the minus it? Well, it's cosine of minus t plus I sine of minus t. And now let's expand this out. This gives you a cosine t plus IA sine of t, or AI, like what is popular now. Cosine of minus t, remember by the trig formulas, that's the same thing as cosine of t. And sine of minus t is minus sine of t. So in the end, we get minus IB sine of t. And then what we get, we can combine the cosines and the sines, and we get a plus b cosine of t plus I a minus b sine of t. And now, since a and b are arbitrary, so are a plus b and I a minus b, so we can just replace them by a and b. And therefore, we get our solution, y, which is a cosine t plus b sine t. So the moral of the story is, whenever you have complex roots, you get some cosine and sine that appears. Little caveat that you may have noticed. I love the word caveat. It sounds like caviar. Because the only issue is, so small issue. Well, here B is really I times A minus B. A and B are a priori complex. Are complex. Which is not really an issue, okay, in our problems, because in our problems, when we solve it with initial conditions, we actually get real A and B. So you can either say that, or you can see that in the notes, because one thing you can do is simply split up A and B in terms of real imaginary parts. Because we can write A as C plus ID and B as E plus IF, and then split into real imaginary parts. real and imaginary parts. And then actually get that, again, because y is real, the real part is y, is actually c cosine of t plus e sine of t, where really c and e are real. C and E are real. So as I said, you have two solutions if you want. Either you can be content and say y is a cosine t plus b sine t, and in practice it will be real, or you can really go one step further, split into real and imaginary parts, and actually get real coefficients. But the moral is still the same. You get cosine and sine.